So we're good? Everybody's got their lesson out? If you don't have it, I can give you another copy to follow along. Y'all got it? Okay. So we paused here. We introduced the notation of a permutation. Now we're going to go algebraic. Say what? It says this. Write each expression without using a factorial symbol. By the way, I like this question, I like this question, I like this question, I like this question. Why would I say that? Pardon me? Did you hear me say it was going to be on the test? Or are you just kind of one of those students that notices when a teacher tends to emphasize certain things? Okay, good. Algebraic simplification. And what you need to realize is that the factorial, the exclamation mark, means 1 less times 1 less times 1 less times 1 less times 1 less. And I'm going to give you a trick to simplifying these, Christina. So for example, it says, write each expression without using the factorial symbol. First one I gave you was NP2, which actually means the first thing factorial divided by the first thing minus the second thing factorial. It means n factorial over n minus 2 factorial. That's not enough. What we want to do is we want to expand these, and hopefully somewhere along the way stuff will cancel. You with me so far, Sean? In fact, I guarantee somewhere along the way, because I'm making up examples where it will happen all the time, stuff will cancel. And the way we start is we look at the top, see it, of the fraction. We look at the bottom, see it, of the fraction. And we ask, which one's bigger? Is n or n minus 2 bigger? Think about it. What's bigger, n or n minus 2? Sorry? You're right. N. That's the one that I start to expand. If the bigger thing was on the bottom, I would start to expand the bottom. In this case, the bigger thing, the n, is on the top. I'm going to expand that in factorial notation. It's going to look like this. N times 1 less. How could I write 1 less than n mathematically? How could I write 1 less than n algebraically? No, even easier than that. Maybe it's too obvious. Like that. Keep going. I want to write 1 less than that. N minus 2. N minus, I could keep going, Sebastian, n minus 3, n minus 4, except I stop here. Why do I stop here? What's on the bottom of the fraction? Can you see it, Sebastian? What's on the bottom? I got to be fussy, not quite n minus 2. N minus 2, factorial. Because I have now matched what's on the bottom, I could write n minus 3, n minus 4, n minus 5, n minus 6, n minus, except I can replace all of that with that. You okay with that, Justin, so far? And why is that nice? Justin, is there an n minus 2 factorial on the top? Say yes. Is there an n minus 2 factorial in the denominator? Say yes. And we're multiplying everything, then I am allowed to cancel. The same as when you have like a 5 divided by 5 or an x divided by an x, or we can cancel. In fact, Sean, can you read to me what's left behind? What 2 terms? The first 2. Read them out to me. N minus 1. That whole thing simplifies to n times n minus 1. Or you could multiply it, FOIL it out. I generally won't. I think that's cleaner. N squared minus n, whatever. Fine, I see some of you looking at me. Let's try another one. It says, write without using the factorial symbol, or simplify. B. Jake, what do you see on the top?
N plus 2.
What do you see on the bottom?
N minus 1.
Which one's bigger?
Top one.
Start expanding that. Okay? So I'm going to rewrite what's on the bottom. If I started to expand that, it's going to be the top times 1 less times 1 less times 1 less times. So the first term is going to be, what's 1 less than n plus 2? Think about it. N plus 1? What's 1 less than that? Just n? What's 1 less than that? What's 1 less than n? N minus 1? Oh, Sean, why am I going to stop here? I just saw the denominator appear. I could keep going, n minus 2, n minus 2. If I replace that all with just that factorial symbol, I can now say, you know what? Ha-ha, ha-ha. I guess that whole mess simplifies to n plus 2, n plus 1, n. I could multiply and FOIL that out. I'm not going to bother. C. C. It says right without the factorial symbol. They've given me a fraction. Which one's bigger? Top or bottom? Ah, the bottom this time. Definitely n plus 1 is bigger than n minus 1. So let's rewrite the top. N plus 1. Sorry, let's try that again. N minus 1 factorial, Mr. Dueck. And let's expand the denominator. I'd have an n plus 1 times an n times an n minus 1. I would come to a stop there. Why would I come to a stop there, Emma? Because I noticed that I now have the term on the top matching on the bottom, and now I can cancel. On the bottom, I would have an n plus 1 and an n. What's left behind on the top? I can't just leave it blank. What must be there? What do I have to put there if everything cancels? A 1. That there fraction simplifies to 1 over n plus 1 times n. Ooh, D. Turn the page. You're not that important. Put it away, Sean. Face down. You're really not.
I'm not.
We've turned the assignment. There you go. Do you see he turned the textbook? He tried to recover, but that was a bad recovery. Sean, my friend, thank you for volunteering to help me with D. Sean, how many terms are there on the top? 2. How many terms are there on the bottom?
2.
You know what I'm going to do in my mind? In fact, maybe even I'm actually going to do that. I'm going to kind of divide this in halves. I'm going to do them at the same time. But in my mind, I'm going to see if I can cancel stuff out in those first 2 and cancel stuff out in those second 2 vertically. I hope. Okay? So I'm going to draw a big fraction bar. Look at the first 2, Sean. The n and the n minus 1 factorials is. Which one's bigger? The top one or the bottom one? I'll start to expand the n. So I'm going to go like this. N minus 1. I'll stop there because that wonderfully matches my n minus 1 that I was stuck with on the bottom. Let's do the next 2. I see an n. So the message is, Brooke, if they give you 4 things, 2 on top, 2 on the bottom, just kind of in your mind draw a line down the middle and cancel out the first 2, cancel out the second 2, and then tidy everything up at the end. I'm never going to give you 6 things. I'm never going to give you 3 on top, 3 on the bottom. And even this I would consider pretty nasty. This was from the old Principles of Math 12, considered a, well, A minus to A level question. This was considered a challenge. Let's keep going, Sean. The n plus 1, the n plus 2, which one's bigger?
N plus 2.
Okay. By the way, I keep forgetting. If I always tend to rewrite the smaller ones so I know what I'm looking for on the bottom, so I don't know what I'm looking for when I'm expanding. So you're telling me I can expand n plus 2 into what? n plus 2 times? Yep. Ooh, Sean, do I want to stop there? Yeah. Yes, I do. Because I think those will cancel. Those will cancel. That whole big monstrosity simplifies into... What's left on top, Sean? You think so? Thank you. What's left on the bottom, Sean? Mr. Dueck, what's the point? Why do we do this? Remember, we said that for factorials, we were stuck with, we couldn't go bigger than 70. This is another way, this is another workaround on your calculator. So if I'd given you that question in D and said evaluate it for n equals 80, your calculators would all crash if you tried the factorial notation. In other words, if you tried typing option, arrow sideways, probability. If you actually tried typing bracket 80 factorial times 81 factorial, close bracket, divided by bracket 79 factorial times 82 factorial, I guarantee my calculator is going to crash. However, if I can simplify it algebraically to this second version right here, hey, 80 divided by 82, that my calculator can handle, no problem. We're going to have to sometimes be clever for workarounds when n's get big. I always try my calculator first because we noticed the NPR was able to handle bigger than 80. So if I can somehow work that in, great. Otherwise, it's which one's bigger, start expanding it until you can reach the point where you can cancel out the other stuff. And then I guarantee you've almost certainly whittled it down to a small enough number that your calculator can handle. Is that okay, Cole? Example 5. Cole, what did I write in brackets, example 5? I should have also written, I like this question, I like this question, I like this question, I like this question. Cole, why would I say that? I have a problem with one of the words you just said. I don't like the word might. Why would I have said that, Cole? Sorry? Did you hear me say it would be on the test? Or are you just kind of the student that tends to notice these things? Oh, okay, just saying. Okay. Brooke, what does it say here? Solve each equation for what? Okay. There's a quick way, which I will allow you to check your answers, but I'm going to demand that you show work. Here's the quick way. The quick way is to guess. To guess. And I'll show you what I mean. First of all, this says XP what? 2. We're picking objects 2 at a time. We just don't know how big the original group is. So I'm going to try on my calculator. By the way, 1P2 is going to give me an error. Why will 1P2 give me an error? This is saying from one object, pick 2 at a time. Can you from one object pick 2 at a time? So trust me, it's going to give me an error. I would start out guessing 3P2. Does that equal 42? Try. Find, what gives you a 42? I'm going to guess somewhere around 5, 6, 7, or 8, but I can't remember what the answer is. Seven? Okay, I'm going to make a little note here so you can, again, I'm going to make you solve this algebraically and prove it, but I know what the answer is. I'm going to make a little note here. Hey, x equals 7. But now we're going to prove it. We're going to solve it algebraically. And to do that, we're going to need to use our actual permutation definition. We're going to write it over here in the margin. In the margin over here, you have room. We defined NPR. We said it's defined as that factorial divided by that factorial. That's how we define. That's what, when you hit the P button, that's what your calculator is doing. The first number factorial divided by the first number, take away the second number factorial. I'm going to fill that in for my example. This would be, I'm going to zoom in a bit more. This would be x factorial divided by first take away second factorial. Apparently that equals 42. You okay with that? I basically took that permutation definition, the one that I gave you way somewhere back here, NPR equals n factorial over n minus r factorial, and I said, okay, I can write this out. Now what? We need to, there is no mathematical way to deal with factorials. We need to get them to cancel. How are we going to get them to cancel? The same way as we got them to cancel in these examples here. We're going to expand them. We're going to expand them by asking, hey, what's bigger on the left-hand side, the top or the bottom? What is bigger on the left-hand side, top or bottom? Top? X factorial? Let's start expanding it. I'm going to rewrite this as x times, what's 1 less than x? X minus 1. Do I stop yet? Not yet. What's 1 less than x minus 1? Ooh, now I'm going to stop because I have an x minus 2 on the bottom. And don't forget to drop down the equals and the 42 because this is actually an equation now. Jordan, is there an x minus 2 factorial on the top?
Yep.
Is there an x minus 2 factorial on the bottom?
Yep.
Woohoo! In fact, I get this. Come on. I get an x dropping down, an x minus 1 dropping down, and a 42. I'm going to get rid of brackets. I'm going to go chunk, chunk. When I do that, I'll get x squared minus x, because x times x is x squared. X times negative 1 is negative x. That equals 42. Yes? What kind of an equation is that? It's a quadratic. How do I know? It's got a squared. How do I solve a quadratic? Now, you guys did this last year. We're brushing off the cobwebs. There's two ways, factoring and quadratic formula-ing. These ones will always factor. They'll always factor. And they'll always factor with the easier method of factoring, the one that you could do in your head from grade 9, not the yucky factoring method. But before I do that, again, Rachel, what kind of an equation is this? It's a quadratic. How do I know? It's got a squared. Before you solve any quadratic, do you remember from last year, what did you have to do first before you did anything else? Make it equal to 0. I think minus the 42 from both sides, yes? That's going to give me an x squared, a minus x, and a minus 42 equals 0. Remember all this? This factors. And to factor it, I'm going to look for two numbers that multiply to negative 42 and add to negative 1. What are two numbers that multiply to negative 42 and add to negative 1? Got only times tables. Can't help you. Positive 6, negative 7? You'd be correct. So this factors into x positive 6 and x take away 7. Remember all this from last year, Foster? It's a while ago. Do you remember what the roots are? What the zeros are? What the answers are? What you're asking is, we're using the zero principle. This is why we factored. Because I have something times something equals 0, what I'm really saying is this bracket could have worked out to a 0, or this bracket could have worked out to a 0. What does x have to be from that bracket? I heard it. Say it louder. -6. What does x have to be from this bracket, from the second bracket? Now, this comes from factorial. Our original equation, Caitlin, had factorial notation, and factorial was number of objects. When I was using factorials like 7 objects or 10 objects, can you have -6 objects? No. So what we do is we're going to cross this out. We're going to write the word reject, much like when Roy asked someone on a date. Reject. Reject. Okay? X equals 7, which we found by guessing and checking, but we just proved it. When I give you one of these on your test, it's probably going to be worth 3 or 4 marks, because there's a lot of work here. 1 mark for the answer, but the rest is going to be for the work, for the steps. We're doing a bit of a proof here. It's also a good review of quadratic equation solving, which is going to come in handy later on this year. That was so much fun. Let's try B. Why, yes, let's. B. XP2 equals 56. Hey, quickly guess and check. What do you think the answer is? By the way, 7P2 was 40-something. I'm going to guess maybe 8 or maybe 9 or possibly 10, but try, which one? What's the actual answer? 8. Okay, we know the answer is 8. Let's prove it. Okay. What we'll start out doing is we'll start out rewriting this without the permutation notation. Something p something means the first thing factorial divided by the first thing take away the second thing factorial. That equals 56. Yeah? Now what? We need to get rid of the factorials. How? Expanding. How? Which one's bigger, top or the bottom? Okay. I keep forgetting to do this, but I usually rewrite the bottom then, the thing that's not being expanded. The top is going to be x minus 1, x minus 2 factorial. That equals 56. And I think, Josh, you agree with me? We can cancel those out, yes? Yeah? Jake. Did I say Josh? Jake. Good gosh, brain. Yeah. Happy Joy? Good. So what I really have is this. An x minus 1, and equals, and a 56. Psst, you're not that important. I'm going to start to take the phones away, folks. Your grade 12s, don't make me take your phones away. Now what? Freezing's not acceptable. Now what? Oh, front door. You see Mr. Rocca, did you? I think he calls it front door bomber. It's really called expanding, but that's okay. So if I hear you correctly, you're saying it's x squared minus x equals 56? What kind of an equation is this? It's quadratic. How do I know? It's got a squared. How do I solve a quadratic? Before I do anything else, what did I have to do? I got to make it equal to 0. I'm going to solve this. X squared minus x minus 56 equals, I'm going to minus 56 from both sides. This will factor. It will. I'm looking for two numbers that multiply to negative 56 and add to negative 1. Change colors, Mr. Dueck. Negative 8, positive 7. We're not done. We factored, but we haven't solved. What were the roots? What would make this first bracket work out to 0? What x value could you put in there? 8. What would make this second bracket work out to 0? Negative 7. Sadly, Roy, once again, reject. Keep trying. Okay. X equals 8, which we guessed, but there's the proof. I think almost one more and we're done. Try this one on your own. See, I'm just going to do it slowly up here. I'm not going to freeze the screen. So if you get stuck, you can look up, but try not. See if you can do this one on your own. Try this on your own. Stop looking up and copying. Try this on your own. Formula sheet? Yep. I just haven't finished typing it up yet. I'll probably have it for you guys Wednesday. Oh, sorry, Roy. Okay. Yeah, for 10 years, it's always been some guy in my class that's been that punchline. Roy's date. Oh, it was funny because when I was teaching Math 12, often kids would actually, instead of writing reject, they'd write the name of the person, their date, as they crossed it out. And as long as you don't do that on the provincial exam, because they won't know what the heck you're talking about, but it's a dumb good way to help us remember the concept of rejecting solutions. Okay. 11, yes? Okay. I have to talk about a technicality here. 0 factorial. On your calculator, what is 0 factorial? Now, this is weird because how can you say if I have 0 objects, there's one way to mix them up? That's really what you're saying. And the reason this is, and also 0 factorial, like 3 factorial, well, that means 3 times 2 times 1. That works just fine. That's 3 factorial. How the heck does 0 factorial, because wouldn't that be 0 times, and isn't anything times 0, 0, huh? We had to actually define 0 factorial to be 0 factorial. Why? Here's why. from 4 objects permutate all 4 of them. Let's suppose we have 4 letters, A, B, C, D. We want to permutate all 4 of them. There's 2 ways to do this. The first way was draw blanks. I'm good at drawing a blank, different kind of a blank. The first way was to go like this. Well, I'm picking 4 objects. And I have 4 to pick from. I've picked 1. How many are left? How many are left? How many are left? 4 factorial, or I think 4 factorial is 120? No, 4 factorial is 24. Okay? But the other way we could do this is our permutation equation. We could go, well, isn't that the same as from 4, pick 4? Permutate 4? And I told you this was defined as the first number factorial divided by the first number take away the second number factorial. Right? Hey, what does that bottom bracket work out to? What is 4 take away 4? This is 4 factorial over 0 factorial. So let me get this straight. Using this method, I got 4 factorial. Using this method, I got 4 factorial over 0 factorial. Foster, Smiling. What's the only way those can be the same if I define 0 factorial to be what? It's got to be a 1 so that I have 4 factorial over 1, 4 factorial over 1. I have to define it that way. Otherwise, our system breaks down. So if you're wondering why 0 factorial is 1, it doesn't work with our 1 less, 1 less, 1 less multiply, because as soon as you multiply with a 0, your answer technically should be 0. We had to define it that way so we get the same answer both ways. Otherwise, we'd have an inconsistent system. Okay? That's a bit of a nerd thing. Erica, you're fine to yawn. No problem. I probably would as well. So last day, I assigned those there. I'm just going to now add from today, because I skipped some stuff last day. 1 is good, 3 to 5 is good. Can we now do number 6? Let me go look. Page 243. I skipped all the algebraic ones, I think. So let's see. Yeah, number 6 is algebraic. So number 6 is fair game. You can just either do them at the bottom, or if you haven't started, you can do them in the middle of the assignment. I'm fine either way. I assigned 7 and 8, 10. Number 11. You know what? I'm going to say 11A. No, you know what? I'm going to say 11B and D. D is a little tricky. I already assigned 12. I already assigned 13. I already assigned 14. Did I want to do 15? Nah, I'll leave 15 off. Okay? I'll leave 15 off. Also, we have a take-home quiz, which I'll hand out right now. So you got lots of time to work on this. Also, if you haven't finished lesson 1, you can finish that. If you have questions, I will be happy to assist you. So take a look at quiz number 1, please. I think you can solve the first few questions using the fundamental counting principle by drawing blanks and going to your Scrabble bag when necessary. Certainly number 1, number 2, and number 3. Number 4, you can either solve using the fundamental counting principle by drawing blanks, or Because we have the word arrange, these are permutations. You can solve this using permutations, using the shortcut, using your graphing calculator if you wish. Either way is fine. We'll mark this first thing next class. Each question's worth 1 mark, so I think it's going to be out of 11. Let me double check. 1, 2, 3. Let's try that again, Mr. Dueck. 1, 2, 3, 4. 5, 6, 7, 8, 9. It's out of 10. That works nice.